Welcome to my projectbazaar.com.
Yeah, let us discuss about the MIMO filter bank multi-carrier system using unique word OFDM. Yeah, let us discuss about the abstract of the product. So the wireless communication is the transfer of information between two or more points that are not connected by an electrical conductor. So the most common wireless technologies use radio. So with radio waves, distance can be short, such as a few meters for television, or as far as 1,000 of even million of kilometers of deep space radio communication. So the MIMO concept, the multiple antennas in MIMO system, can be explored in two different ways. One is the creation of highly effective antenna diversity system, and the other is the use of multiple antennas for the transmission of several parallel data streams to increase the capacity of the system. So the antenna diversity is used in wireless system to combat the effects of 5G if the multiple independent copies of the same signal are available in the process. So combine them to a total signal with high quality of the process, even if some copies of exhibit the low quality of the images. So in this proposed work, to overcome the frequency selective channels by using the OFDM, so that is the orthogonal frequency division multiple access, to achieve the high spectral efficiency by using the filter bank technique, so that is a FB. And the proposed work, a new carrier with filter bank, that is FB, and unique word OFDM techniques are combined together, that is FB UW OFDM. So the cyclic prefix, that is CP OFDM, is used to instead of UW OFDM, unique word OFDM, and also UW OFDM has better performance compared to the cyclic prefix OFDM. So overall the process simulation is done by using the MATLAB. Yeah, let us discuss about the flow diagram of the process. So generate the, first of all, it has a transmission model, a channel, and then receiver model. So in the transmission model, it has a process of generate the input data, conventional encoder, serial to parallel conversion, modulation of QAM, that should be quadrature amplitude modulation, and then pilot carrier insertion, and then IFFT, FBMC modulation. So these are the parameters including in the transmission model. In the channel, we have using the AWGN Raleigh fading channel, that is the additive wide Gaussian noise process. The receiver model, it should be in the inverse of the transmission model. It has a FBMC demodulation and then FFT, adding the zero forcing and pilot carrier removal. So demodulation occur using the QAM modulation and parallel to serial conversion, and then finally decoding of the process. Finally, the performance analysis will be calculating the bit error rate and the ACR of the performance. So the elaborated we discuss about the transmission model. So the OFDM transmitter, initially input signal is generated randomly by using the convolutional encoder, can convert the input signal into the binary stream. So adaptive modulation scheme is used for modulating the input signal, for which the 16 QAM or 64 QAM modulation schemes are used. So in a particular the block type pilots, all the subcarrier in some OFDM blocks are reserved as a pilot tones. So in combination type pilot models, some predefined subcarriers in each of the blocks serves as a pilot. The Fourier transform breaks a signal into different number of frequency bands, so by multiplying the signal with a series of sinusoids. So this is essential translate the signal from time domain to the frequency domain of the process. So and then the filter bank. So here we using the filter bank of the concept is an array of bandpass filters that separates the input signal into multiple components. So each one carrying a single frequency, that is each one carrying a single frequency subband of the original signal. So it carries a multiple frequency. So it's each one carrying the single frequency for the subband of the original signal. So one application of a filter bank is a graphic equalizer, which can attenuate the components differently and recombination them into a modified version of the original signal. So that is the process of each signal carrying the subband of the process. So the process of the decomposition performed by filter bank is called the analysis. So that is the meaning analysis of the signal in terms of its components in each subband of the process. So these are the overall process of the FBMC modulation or like that. So and then finally calculating the performance analysis. So in the output of analysis is referred to as a subband signal, which is it's a filter bank reconstruction process, is calculated as a synthesis, meaning reconstitution of the complete signal resulting from the filtering process. So calculating the performance analysis by using the bit error performance and the ACR of the symbol error rate of the process. So these are the overall overall flow diagram of the process. Yeah, let us discuss about the running procedure for the process. So click the main file and then run. So it has time. So it has some time to enter the process. So I will enter the data value like 64. So and then enter the block size. Each block it has a size. So I will here we are using the 8. So whatever values it may be used, I will select the 64 and 8 of the process. So this many simulation graphics will display. So I will click the first of all the transmitted input signal. So the transmitted input signal, yeah, this is the first figure. In this first figure, transmitted input data randomly, and here we using the data points is generated randomly, and also transmit the input data phased representation of the process. So this is generating the input data by using the randomly of the process. And then in the next figure, there is a modulated transmitter data. Here we using the input data and then randomly, and then generating the modulated transmitter data by using the QAM modulation. So that's the quadrature amplitude phase shifting keying. So by using the QAM mod syntax to transmit the data into the input to the output of the process. So this is the figure, the modulated transmitter data of the process. Yeah, and then generated the signal. So here we using the x-axis represent the time and y-axis represent the amplitude. Here we using the signal, that is a OFDM signal. By using the input data and then modulation, OFDM signal it should be generated. So like it's at a peak, so represent as the signal likewise. And then SINR comparison. So for MMSC, n equal to 128 and ns is equal to 32. Compared to this n of number of antennas representing normalized frequency, so it should be high compared to the MMSC ns is equal to 32. So these are the comparison of SINR comparison of the graph. So in the next figure, similarly the same figure. So SINR comparison, just is a SINR comparison. In the next figure, SINR comparison, k is equal to 6. So compared to this, k equal to 6 multiple with the 6 value. So the SINR it should be increased. So these are the difference between the SINR comparison as a solid static value and then k is equal to 6 value. So these are the difference between the SINR comparison statically and k is equal to 6 of the process. So in this next figure, yeah, this is the FBMC. So there's a filter bank modulation code. It has a number of peaks it should be represented, and then normally OFDM peak. So this is the normally OFDM generator of the peak. It has a FBMC filter bank. So it will be filtered the more number of peaks and represent the multiple curve of the process. So compared to the OFDM process, FBMC is efficient to take the value of the process. And then the next figure, yeah, in this figure there are proposed our 3 works. One is a self-equalization, another one is a CFO analysis, another one is a pilot contamination. So in the self-equalization process, it has a AC 1, 2, 3. So the average EP by NR, that's the error value, and then bit error rate. How should be the error value? It should be decreased compared to the SE1 and SE3. SE2 is better of the self-equalization process. And then the next figure is analysis the CFO analysis. So in the CFO analysis process, the same process it will be implemented, the average CP by NR and then bit error rate. Compared to the CFO01 and CFO03, compared to the CF02, it should be very reduced of the angle. And similarly for the pilot contamination. So pilot contamination process, PC is equal to 1, PC is equal to 2, PC is equal to 3. Compared to all the process, PC is equal to 3, very much lower than the process. So these are the 3 graphs for the represents the bit error rate of the process. So these are the overall running procedure.
Thank you for listening this video.